Hey guys, in this video I'm going to be showing you how to create this third-person controller here that supports movement in all directions, friction and acceleration, and slope movement as you see here. It also has a variable jump and it even supports joypads and controllers for consoles such as the Xbox and Nintendo. So if you want to know how to do this, make sure you watch till the end of the video where I will also have a special announcement. So make sure you stay till the end. Anyway, with that said, let's jump right into this video. So to get started, we are in a new scene here and we're going to add a kinematic body. Then we're going to go ahead and rename this kinematic body to player. Then with the player selected, I'm going to go ahead and actually add a mesh instance as a child of it. I'm going to actually select that mesh instance and rename it to skin. Then I'm going to go over to the inspector on the mesh empty, and then we're going to do new capsule shape. We're going to click on the mesh once more and give it a radius of 0.5 and a mid height of 2. Then I'm going to simply rotate it along the x-axis by 90 degrees to make it stand upward. And then I'm just going to move it so that it's flush with the floor. Anyway, that looks good to me. So now with that, I'm gonna go ahead and actually select the player once more, and I'm gonna go ahead and add another mesh instance. In this case, we're gonna go to the inspector, mesh, new cube mesh, and I'm gonna move this into place where I want it to be, and I'm gonna actually click on mesh here and then give it an X of 0.2, a Y size of 0.2, and a Z size of 2. That looks fine to me. I'm gonna move it into place, and this is gonna be used to tell what direction my player is facing. So we're going to be facing the negative Z direction in this case. Anyway, with the skin selected, I'm actually going to apply a material. So I'm going to go over to the inspector, and then in the mesh properties, there should be an option for material. You can click empty, new spatial material, click on the material once more, go and click albedo, and then you can select a color. In this case, I'm going to give it a blue color. Now, I'm going to do the exact same thing with the other mesh instance. So, I'm going to click on the mesh, make sure that I open up the properties, click material, empty, new spatial material, albedo, and select the color. In this case, I'm choosing orange, and now I have this platypus, Harry the Platypus capsule bean. So anyway, we're going to select the player, and we're going to add a collision shape as a child of it so that we don't get that error anymore. We're going to go into the inspector, shape, empty, new capsule shape, and then we're going to click on it and then give it a radius of 0.5 and a height of 2. We're going to leave the margin, and then in the viewport, we're just simply going to rotate it on the X by 90 degrees and move it into place so that it actually covers my mesh instance or my player body. And that looks fine to me. So let's actually proceed. So select the player, and now what I'm gonna go ahead and add is very important. So we're gonna add a spring arm, and we're gonna actually move it into place roughly where the head would be for our player. And this looks about all right to me. Yeah, that looks fine. So now I'm gonna actually go over to the inspector, and then I actually want to set up a spring length for this. So in this case, I'm gonna give it a spring length of 6, which should actually work fine for this. And now we will see this line appear here, which is basically a raycast that our spring arm makes use of. Anyway, we're gonna add a camera as a child of the spring arm, and we're actually going to move this camera in a little bit, but basically let me explain how the spring arm works. So the spring arm has this raycast that checks for collision. So if this line here collides with anything, it will actually move the camera automatically to just before the collision point. So if I have a collision right here, the camera will be moved right here before the collision, and so that the camera doesn't clip, into the wall, essentially. And this is built into Godot. So if I actually save my scene here and run it, you will see that the camera is actually automatically moved to the end of the raycast from the spring arm. And this is done automatically, or it will be moved to the point of the collision or just before the collision. Anyway, I'm going to preview the camera, and I'm going to actually do Control 2 so I can actually have 2 viewports here, and I'm going to move the camera here to roughly the view that I want. Now, you don't have to do this, I'm just doing this so that I have a better idea of what my end view is going to be, since the camera is automatically moved by the spring arm towards the end of the spring arm raycast, essentially, like I said before. And then I'm just rotating the spring arm and the x-axis to just get a view of the top of the player roughly, and I think this view will work fine. So let me just check it out, and yeah, this view will work just fine. You can change it a little bit if you want on your end. Anyway, with that done, that actually is the basic setup of our player. Now we can actually add a script. So we're going to add a script called player, and we're going to make it be empty. Now, to get started in this script, we want to start by adding a bunch of export variables. So in this case, we're going to start by doing export var max speed, and we're going to set it to a default of 10. Then we're going to do export var and then gravity, and we're going to use something like -40, and then export var, let's see, we're going to do the acceleration next, which is equal to 270, and these values I pretty much just got through trial and error. You can adjust it to however you want though. So we're going to do export var friction is equal to 60, export var air friction, and this is going to be something lower than my normal friction, so we're going to have two frictions, one for the ground and one for the air. So in the case of the air, we're going to give it a value of 10, which is much lower than our friction for the ground. Anyway, we're going to do export var jump impulse is equal to 20, and we're just moving our gravity just to be directly above the jump impulse, since it makes a little bit more sense. Anyway, we're going to do another export var for the mouse sensitivity, which is going to be set by default to 0.1, and an export var controller sensitivity for our controllers. So in this case, it's going to be set to a default of 3, and the reason we're doing export vars is so that we can easily access them from the inspector here, so we can adjust them if we want while testing the game out. Anyway, let's actually go back to our script here and actually define a couple more variables that we need. So it's going to be var velocity is equal to vector3.0, and then we're going to do var snap vector is equal to vector3.0 as well. Then we're actually going to be using that snap vector in a little bit, well, in the future here in this video, to support slope movement. Anyway, we're going to do function ready, and inside that function we're going to do input.set mouse mode is going to then inside the parentheses be input.mouse mode captured, and basically this is going to set our mouse mode to be captured. So if we launch the game right now, you will see that we don't actually see our mouse because it's being captured. Now we actually need a way to toggle between captured and visible so that we can actually close our game. So to do this, we're going to actually do this in a func under unhandled input. So in this unhandled input function, we're going to do if event is action pressed, and I actually haven't set these actions up, so I'm going to go to project settings, input map, and start defining a bunch of actions that we're going to be using for the game here. So we're going to actually start by defining a click action. So in the action field, just type in click, and then you can click on the plus sign to add a key here. So in this case, it's going to be the mouse button, and in this case, it's going to be the left button. You can change it if you want. Anyway, we're going to define another action. In this case, we're going to call it toggle mouse captured. And this is what we're going to be using as the key to toggle our mouse mode essentially. And in this case, we're giving it a key of escape. And while I'm at it, I need to define all the other actions that we're going to need as well. So in this case, let's start by defining our input actions. So move forward, and then we're going to do move right, and then move, let's do it move back. That's what we're going to call it. And then move left should be the last one we need. Now, that's for the input. Now we need a couple more, such as for the jumping, so action jump, and then we need some for the controller support as well. So in this case, we're going to call this actions for the controller, look up, look underscore right, look underscore down, and look underscore left, like so. And now I can actually start adding the keys for this. So click on the plus button for move forward. In this case, it's going to be the W key, and I'm also going to add a joy axis to it. And in this case, it's going to be the left stick up since we're moving forward. And then do the exact same thing for the other actions. So move right is going to be D, and it's going to be a axis of left right, so left stick right, and then move back is going to be S, and then a joypad axis of left stick down, and then move left is going to be A, and left stick left. Then for the jump, we're going to use the space key, and we're also going to use a joy button. In this case, you can set it to whatever button you want. I think I'm going to actually set it to be the Xbox B button, so that's what I'm going to go with. So click and add it, Then for the look up, we're only doing this for the controller, so all we need is a joy axis. So in this case, it's gonna be the right stick up for the look up, the look right is gonna be the right stick right, and then the look down is gonna be the right stick down, or yep, like so, and then the look left is gonna be right stick left. And that should actually do it for all the actions that we need for this specific controller. So back in the script, inside the is action pressed, we're gonna check for the click action that we set up. And then if this is the case, then, and let me actually make sure that I actually called it click, and it is. So if this is the case, we're gonna do input.set underscore mouse mode, and then we're gonna set it to the input mouse mode captured. Then we're gonna do another if statement. So if event is action pressed, and then this time it's going to be the toggled mouse captured. If this is the case, then we're gonna do another if statement. So if input.get mouse mode is equal to the input.mouse mode captured, meaning that our current mouse mode is set to be captured. If this is the case, then we actually want to set the mouse mode to be visible. So to do this, inside that if statement, we're just gonna do input.set mouse mode to input mouse mode visible to actually show our mouse. And then we're gonna do else input, and we're just gonna actually copy this line here. So we did Control D to duplicate the line. So else it's gonna be input.set mouse mode to input mouse mode captured. So that basically toggles the mode of our mouse essentially. So if we press the escape key, it will essentially toggle between visible and captured. Also, if we click on our screen, it will also set the mouse mode to captured, as you can see here. So that's done for that functionality. That's all we need. So now we're gonna move on to the other functionality. So we're gonna do func physics process delta, and then we're gonna start by doing var input vector is equal to get input vector, which is a function that we're actually gonna define right here. So func get input vector, and then what we're gonna do inside this function is we're just gonna do var input underscore vector is equal to vector3.0. Then input underscore vector dot x is equal to input dot get action strength, and in this case it's going to be move right minus the input dot get action strength move left. And then I'm just doing Control D to duplicate this line, and instead of dot x it's going to be dot z, and then instead of move right it's going to be move back, and instead of the move left it's going to be move forward. Now this logic here is dependent on your player's or your character's orientation. So based on the orientation of your player, it's gonna be different. So in this case we're facing the negative z direction to go forward, so that's why we defined it this way. Now if we actually wanted our player to be facing the positive z direction, so like this here, so if we're facing this direction, then we would actually modify this code to be the opposite. So it would actually be the move left minus the move right, the move forward minus the move back. So this just depends on the orientation of your player. Anyway, I'm just gonna do Control Z to undo that and then go back to the script. So now I just want to return the input vector dot normalized if input vector dot length is greater than 1, else we're gonna just return the normal input vector. And the reason we're doing this is because dot normalized essentially tries to return a value of 0 or 1, meaning that if we're not pushing the analog stick on our controller all the way, it will just by default try to be a value of 1. So we don't actually want to do this for our controller. That's why we did it like that. Anyway, let's actually do another function, which in this case is going to be the get direction, and for now we're just going to do pass. We're going to make use of this function a little bit later. Anyway, with that function now there, we're going to do another function, and in this case it's going to be the function to apply our movement. So function apply movement, and it's going to take an input vector for now, and inside the function we're going to do velocity, and actually it's going to be velocity.x, I think. So it should be velocity.x is equal to the input underscore vector.x times my speed, and in this case I think I called it max speed. Yes, I did. So just duplicate that line and change the .x to .z, and that should actually apply our movement already. So to make sure you actually call that function inside the physics process. So apply movement and then pass the input vector to it. And we should actually be able to move now, but we need to add this line as well. So velocity is equal to move and slide velocity and then our up direction. So in this case it's the vector 3.up, and you can control click on move and slide to read up on it, and then the vector 3.up essentially returns the vector that's 0, 1, 0 like this. So if you can control click on it, as you see, it returns the vector that's 0, 1, 0 like I just said. Anyway, if we test this out, and we won't actually be able to see it if we run the local scene since our player's on the void. So I actually went ahead and I already created a test level that we can test our controller in. So let's go ahead and instance in our player in this test level that I made, like so, and then let's just click play. And as you can see, we can actually move our player around now, but we can't actually move the camera around. So let's actually add the functionality to be able to rotate our view. So to do this, we're actually going to go into the function unhandled input, and we're going to start by doing another if statement. So in this case, it's going to be if event is event, or if event is input event mouse motion, and input dot get mouse mode is equal to input mouse mode captured. So I'm just going to control copy this line and paste it. If this is the case, then I'm going to go ahead and do rotate underscore y and then dig to rad, and inside the dig to rad I'm going to do minus event dot relative dot x times my mouse sensitivity. And then I'm gonna actually go up here and define a onReady var. So onReady var spring arm is equal to $spring arm to select my spring arm. Then inside the if statement we were just writing, we're gonna do spring underscore arm dot rotate underscore x dig to rad minus event dot relative, and in this case it's gonna be dot y times my mouse sensitivity. So it should actually already be working. So this line right here basically handles the horizontal movement, and the spring arm line handles the vertical movement. And as you can see, it's already actually working, but there's a slight issue where, as you will see here in a little bit, if we actually move and rotate our view, we are still actually not moving in the direction we're facing when we press forward. So that's an issue. And another issue is we can actually rotate our camera like so. So we actually need to limit our camera vertical movement. So to do the vertical movement and limit it, we can do this line of code here, which is spring underscore arm dot rotation dot x is equal to clamp, and then what is the value we're clamping? We're clamping the spring underscore arm dot rotation dot x, and then the min value that it can be, so it's going to be dig to rad minus 75, and then the max value, which is going to be dig to rad 75. You can control click on clamp if you want to read up on it. Anyway, if we test this out now, that should fix the issue with the camera being able to rotate all the way around the player, and it does. Now let's actually fix the movement here, and that's where our get direction function is going to come into play. So we're actually going to pass our input vector into this function, and inside the actual function what we're going to do is we're going to do var direction is equal to input vector dot x times, then in this case it's going to be the transform dot basis dot x close parentheses, and then plus, and then parentheses input underscore vector dot z times transform dot basis dot z. Then we're simply returning the direction like so. Make sure you actually call it in the physics process. So we're going to call it right after the input vector. So we're going to do var direction is equal to get direction, and we're going to pass our input vector to it. Then inside the apply function, we actually want to pass a couple more values to it. In this case, we're going to pass the direction and the delta values to it as well. Now let's go over to my apply movement function, where I'm going to make sure that I'm actually passing these values. So make sure that you pass the direction and the delta to it as well, and we can actually get rid of this code now. And now in this case, we're going to actually do if direction is not equal to vector 3.0, if this is the case, then we're going to do velocity.x is equal to velocity.move toward the direction times my speed, and then add a rate of acceleration times delta. So this is basically adding the support for acceleration in our game, and we want to make sure that we put .x at the end of this, and it should actually be max speed, not speed. And then we can just duplicate the line and change the .x with .z. So that should actually do it for this now. So like I said, it's moving our velocity.x and z towards the direction times max speed at a rate of acceleration times delta. So if we actually test this out now, we should actually be able to make it work now, and it is actually working. So when we press the W key, it will actually move forward to the direction that we are facing. And as you see, there's still a couple issues. For example, we still don't have gravity in the game. So let's actually go ahead and add the gravity so we don't have that issue anymore. So func apply gravity, and then inside this function, all we want to go ahead and do is velocity.y is equal to, and actually it's going to be plus equals, the gravity times delta. So make sure that you actually pass the delta value to this function. Then we're going to actually clamp the value that the velocity.y can be so that it doesn't increase forever, essentially, while we're falling. So velocity.y is equal to clamp velocity.y, which is the value we're clamping, and then the min value it can be is the gravity, and the max value it can be is jump impulse. Then make sure you actually call it in the physics process, so apply gravity and pass delta to it. So with that, if we test the game out, we should actually have gravity in our game now. So let's test it out, and as you saw, we can actually fall now. Now there is another issue. You probably can't tell, but as the code is right now, we can't actually stop our player. So that's an issue that we need to address here. And let me just make sure that it is the issue I'm talking about. And yeah, we can't actually currently stop the player. So to stop the player, we actually have to apply friction to our player, because currently we're not actually doing that. So we're gonna do func apply friction. And inside this function, we're going to do if direction is equal to, now I know I put not equals to vector 3.0, but it should actually be direction is equal to vector 3.0. I do fix this here later in the video. So anyway, inside that, we want to do if is on floor, velocity is equal to velocity dot move towards the velocity or vector 3.0. So we're moving towards a value of 0 at a rate of friction times delta. So we want to pass our direction to this function as well as our delta value. So I actually want to make sure that I actually call this function in the physics process. So apply friction and then pass direction and delta. And as we test it, it's actually not working because, like I said, I kind of messed up where I actually set it to check if it's not equal to vector 3.0 when it should actually be if direction is equal to vector 3.0. So here I'm just checking to see where the error is, and I finally did notice it and made the change here. So it, like I said, it should be if direction is equal to vector 3.0. Now if we run the scene, it actually is working. So if you just want the very basics of a third-person controller, then this is pretty much all you need. So I am going to add more functionality though. So I'm going to start by actually adding different friction values for when we're on the floor and when we're on the air. So I'm just control copying the lines of code above. So the velocity.x is equal to the move towards direction times max speed, and in this case it's going to be air friction times delta. So make sure that you actually change the lines there to be like follows. So anyway, with that now done, we're gonna do func jump, and then if input that is action just pressed, and we need to define our jump function because we can actually test out our air friction without being to jump. So anyway, back in the if statement we're writing, if we're pressing the jump action, we're doing velocity.y is equal to jump impulse. Then to actually add the variable jump, all we have to do is if input that is action just released jump and velocity.y is greater than my jump impulse divided by 2. If this is the case, then the velocity.y is going to be equal to the jump impulse divided by 2 instead. Now let's actually make sure that we call the jump function up here in the physics process. And now if we test the scene out, it should actually be working, and it is, as you can see. So there we go, we have a jump in our game now, which is fine. And there's some weird clipping with the camera, so we'll fix that here in a little bit. But let's actually go to our player scene, select the camera, and make sure that the far is increased to a higher value. In this case I used 200. You can change it to whatever value suits your game though, and that fixes the clipping of the camera. So now let's actually add the rest of the functionality that we need, and let me actually test something here. So actually, let me actually show you. So currently the controller that we're using doesn't actually support slopes. As you can see, we're slowly sliding down the slope. So to stop this from happening, we need to change some code here. And that is, we want to go over to the move and slide function, and instead of, well, where we're calling move and slide, and instead of move and slide, we're going to do move and slide with snap. So the move and slide with snap actually takes a couple more parameters than the normal move and slide. As you can see here, it takes an up direction, a stop on slope, which is by default set to false, max slides, and so forth. Anyway, we don't have to actually define each value, but we do have to define a couple more. So in this case, we're passing the snap vector, which we define up here, right after our velocity, like so. And then right after the vector 3.up, which is our up direction, we're setting true for the stop on slope. So now, if we actually test the scene out, we should actually stop on the slope and not slide down. And as you can see, it is actually already working. Now we still do want to do a couple more things to make sure that it's working as intended. So what I'm going to be doing here is I'm actually going to go into my and actually I'm going to start by creating a new function. So in this case it's going to be func update snap vector. So in this function, all we're going to do is snap underscore vector is equal to minus get underscore floor underscore normal if it's on floor, else vector 3 dots down. So now it should actually work as I intended. So let me actually test it out, and we aren't sliding down the slope, and we shouldn't be able to jump as it is right now, and it seems like there's something wrong since we can jump, and we can actually jump quite a bit. So there's a couple errors, so let's actually fix those errors. So first let's fix the jump error here, and I think it's because I forgot to add a additional condition to the if statement. Before I actually do that, let me actually make sure that I actually call the update snap vector up here and make sure that that's the issue first. And it seems like that was actually the issue. We just forgot to actually call the function, and as you can see, we can't actually jump anymore. And that's because if you can control click on the move and slide with snap, as you will see here, it will basically snap to the surface, and you need to disable the snap in order to actually be able to jump. And we do this by doing this in the jumping function. So we want to do it snap vector is equal to vector 3.0. So that should actually allow us to jump now again. But like I said, we actually want to add another condition to the if statement that we forgot, and that is n is on floor. So now we shouldn't actually be able to jump without n, and we should actually be able to jump and actually snap to slopes without sliding. And as you can see, it is actually a variable jump, as you can see when I'm actually comparing it on the wall here. So if I hold the button longer, the higher I actually jump. Another thing, like I said, the reason we're using a spring arm is if we actually get close to a wall like this, the camera will automatically be moved to the collision point or just above the collision point, so we don't actually clip through the wall. Now there is a little bit clipping, but for the most part it works well enough. Anyway, with that fixed, let's actually go ahead and add support for our controller. So we're going to add a new function called func apply controller rotation, and inside this function we want to do var, and let's call it what am I gonna call it? Let's call it something like axis vector is equal to vector 2.0. In this case, we don't need a vector 3, a vector 2 is good enough. Anyway, we're gonna do axis vector dot x is equal to input dot get action strength, and in this case, it's gonna be the look right minus the input dot get action strength look left. And then I'm duplicating that line with Control D and then changing the dot x with dot y, the look right with look down, and the look left with look up. Like so. Then what I want to do is an if statement. So if input event joypad motion, if this is the case, then I want to do rotate underscore y, dig to red, and then minus axis vector dot x times controller sensitivity. And then I'm duplicating that line, and then I'm gonna do spring arm, and it should actually be spring underscore arm that rotate underscore x deg to red minus axis underscore vector dot y times the controller sensitivity. And in this line of code right here, we actually have to move it, and I'm actually going to show you why here in a little bit, but make sure that we actually call this apply controller rotation function in the physics process. Now, if I run the code here, you will see the issue I was talking about where our camera movement isn't actually being limited in the vertical direction when we use the controller. So to fix that, we're simply going to move this one line of code here right after the apply controller rotation function call. So now if we test it out, the controller movement is actually working as intended. And actually, I think there's a slight error. And let me check if it's in my code here. And everything looks fine. So I think it's in my input map. So let me make sure that I set my input map correctly. And just as I thought, I actually set up my move back action for the joystick wrong. So it should actually be left stick down for move back. Now, if I actually test it out, it should work as intended, and it actually does seem to be perfectly working like I intended. So now we have a character controller that you can jump in, support slopes, you can move with the controller or the mouse, and everything is working as intended, like I said. Now, I'm just going to check my project settings here, and I'm actually going to change the jump to be the A button on the Xbox controller instead, because with the B button it was feeling a little bit weird. Now we're going to do one last thing, which is we're going to add a position 3D to our player. You could also use a spatial, and I'm just going to rename that to pivot. And then I'm going to actually move the skin and the mesh instance as a child of the pivot. And the reason we're doing this is it doesn't really make sense for our player, if we were actually playing an animation, to keep facing forward if we're moving to the right direction. So in order to fix this issue, we're going to make use of this pivot. So on the top of the script, we're going to do onReady var pivot is equal to $pivot. And then we're going to scroll down here, and then in our apply movement function, we're just going to add this line, and this is the easiest way you can do it. So the easiest way you can do it is just do pivot.lookAt global underscore transform.origin plus direction, and then comma vector3.up, and you can control click on lookat to read up on what it does if you want. Anyway, if we actually launch the game and test it out, as you can see, when we click to move left or right, our character actually rotates in that direction. Now it is a bit clunky, so in order to get a smoother movement, we're actually going to finally make use of the input vector here, and instead of the pivot.lookAt, we're going to do pivot.rotation.y is equal to lerp underscore angle. And in this case, it's going to take the pivot.rotation.y, comma, and then atan2, and then minus the input vector dot x, comma, minus input vector dot z, like so, and then comma, and then it's going to be at the rate we're moving, so it's going to be 25 times delta. And you can click on lerp angle to read up on what it does as well if you want, and it should actually be working now. But I'm actually going to define another export var at the very top to actually handle this movement. So we're gonna call it ector_var rot_speed, and by default we're gonna set it to that 25, and instead of 25 down here, we're just gonna do rot_speed times the delta. And now, as you can see, the movement for the player rotating in the direction we're pressing the key in, it's a lot smoother. Now you can actually adjust it from the inspector if you want, or from the code. I'm just going to change it to 30 in the code just to get it to be a little bit more smoother. And as you can see, our player controller is fully done now. So we can go up slopes and not slide. We can actually jump around, move around. It has support for controllers and so forth. So everything seems to be working. So with this, we're actually done. So I'm actually going to be leaving a link to the GitHub project for this particular project in the description, and you can use it for whatever you want. Feel free. Now, if you made it this far, then you're absolutely amazing. And I actually have a special announcement. So currently I'm working in an online multiplayer course for Godot, where I'm actually going to be showing you how to make a game similar to Mario 35 using Godot's built-in high-level multiplayer API. So if you're interested in this, I'm actually going to release this on Kickstarter. So you can actually find a link in the description to the Kickstarter page where you can follow the project if you're interested. And I'm actually going to have more details about this in the near future, probably later this week and the following week. So look forward to that. Anyway, with that said, if you liked the video, make sure you leave a like and consider subscribing, and I'll see you guys in the next one.